Hello dear students, as we have started rearrangement reactions, we have already seen Beckmann rearrangement. Our next rearrangement is Schmidt rearrangement. So let us see the mechanism for Schmidt rearrangement and what is Schmidt rearrangement. So in Schmidt rearrangement we use carboxylic acid. It is a rearrangement of carboxylic acid into primary amine. So this is step down synthesis. It means reactant having product have one less carbon compared to its reactant. Okay, so here you can see the mechanism. In first step we have used acid to protonate our oxygen. Okay, here you can see oxygen get protonated. After that we have treated this with soda amide. Soda amide is a nucleophile which attacked on an electrophilic center, that is carbonyl center here, and we get structure like this. And then this, after this, water is removed. One hydrogen from nitrogen, and here of OH. Okay, H2 is removed. Here you can see this. Okay, this species will form. I have just shown its tautomeric form, nothing else. Oxygen shifted towards here nitrogen. You can see oxygen and nitrogen. Okay, pi bond is shifted. Okay, this is tautomeric form, and after this structure is formed, nitrogen gas N2 is removed. Okay, and nitrine is formed here. This nitrogen becomes electron deficient. How? Because electrons involved in this bond formation, nitrogen will taken by this nitrogen. Okay, and this nitrogen becomes electron deficient, and as we know that what is nitrine? Nitrine is the electron deficient species. Okay, nitrogen analog of a carbene. And then rearrangement will take place on this nitrine. So what is our first step of this mechanism or Schmidt rearrangement? Formation of this nitrine. Okay, and when nitrine is formed, then rearrangement will take place. Simply group attached to the carbonyl center will migrate towards the nitrogen. Okay, and further what happened here, you can see group which was attached here to the carbonyl center migrated toward nitrogen, and lone pairs form bond over here. Okay, now what is the next step? Attack of water molecule. H2 attack on carbonyl center, electrons involved in pi bond formation of oxygen and carbon migrated towards oxygen. Here you can see in the next structure water get attacked. Okay, and oxygen get negative charge. Again what happened? Deprotonation, and we get our final product. After decarboxylation we get our final product, primary amine. Okay, decarboxylation how takes place? Negative charge on oxygen or electrons on oxygen forms pi bond here, and because of that this carbon nitrogen bond break down. Okay, and this hydrogen takes by nitrogen. Okay, so this is primary amine, our final. So this is our final product, primary amine. Always remember this, primary amine is our final product. And as I have told you that this is step down synthesis, it means product have one less carbon compared to reactant. So in this structure we have only one carbon, but in, as you can see here, our reactant has two carbon, one carbonyl carbon and this CH3, one carbon from this CH3. Okay, in this reaction we always get primary amine, remember this. Okay, I hope you understand this. Let us continue towards our examples. Understand this mechanism and then try to solve examples. I have given examples with answers. Okay, if you have to find out only answer or only product, there is a very simple way. What you have to do, just replace this carboxylic group with NH2. Okay, this is the answer. Here also we have replaced this with NH2, we have replaced this with NH2. Okay, answer is very simple, just you have to know the mechanism. Mechanism is important for your examination point of view. You have to focus on mechanism. Okay, so I have also given here some theoretical part which you can use for your further information, how mechanism takes place, why something happens. I have already explained it, but for your extra information you can refer this. Thank you.